Let's get started on your notes over compound inequalities. So what are compound inequalities? They're just multiple inequalities in one problem. So today we're going to be looking at two different types of compound inequalities. The first I'm going to call or inequalities, and the second are and inequalities. So when you see an or inequality, you'll see the word or in your problem. And your solution occurs when either of the inequalities is true. So if I have two inequalities right here that I'm looking at, my solution set can be x is less than 1, or it can be x is greater than or equal to 5. Either of these solutions would work. So if I were to graph this or inequality on this number line, I'm going to graph x is less than 1, and so I put an open dot at 1 and I shade to the left. And then I'm also going to graph x is greater than or equal to 5, so I'm going to put a closed dot at 5 right here, and I'm going to shade to the right. So we're looking at solutions to these compound inequalities, which these would be your solutions, and then we're going to graph them so we can visually see, or we have a visual representation of these solutions. So typically your OR inequalities are going to look like this. Okay, I'm not getting into any special cases or anything, but I mean, obviously these dots right here, they could be filled in or not filled in, but the arrows tend to go out in either direction. Okay, so those are your OR inequalities. Obviously there are special cases, and I'm not going to go over those special cases today. I'm just going to go over what you typically see. So then looking at your and inequalities, your solutions are between two quantities. Both inequalities are true at the same time. So let's say I have these two inequalities right here. X is greater than or equal to -2, and x is less than 7. So if I graph x is greater than or equal to -2 on my number line, I'm going to put a closed dot at -2, and I'm going to shade to the right. And then if I graph x is less than 7, I'm going to put an open dot at 7, and I'm going to shade to the left. Your solution in an and inequality is the overlapping region. So if I need x to be anything greater than or equal to -2, and x can be any number less than 7, your solution has to satisfy both of those. I need this and this to have a solution. So my solution set is just right here in this overlapping region. And so that's all you really graph whenever you graph an and inequality, is you just graph the overlapping part. So what I really like to do, this is a way that you can write your and inequalities, where you have your variable in the middle, and typically you have your smaller number to the left and your larger number to the right. Your arrows typically point to the left, and I'm going to just kind of walk through how to read this because this is really confusing to students. So I always say you can read your inequalities from left to right. Well, this first little part right here, I'm actually going to read it from right to left. I'm going to read x is greater than or equal to -2. So close dot at -2. And then on the right side of my inequality, when I read it, I'm going to read x is less than 7. So I have an open dot at 7, and I shade to the left. So I like these and inequalities written like this because I have my two endpoints, -2 and +7. Because this is an or equal to, I know I shade in -2. This does not have an or equal to right here, so I don't shade that in, and x can be anything in between. So your solutions are between those two quantities. So let's move on. Let's practice graphing compound inequalities. So the directions say draw the graph for the given compound inequality, and we're given two of our and inequalities first, right? Where our solution is going to be between two endpoints, and my solution must satisfy both inequalities. Simple inequalities, if you will. So here's how I like to graph these. Negative x is everything in between -4 and +5. So I'm going to put a dot at -4 and positive 5. And I can put it on my number line or above it. I'm just going to do it above it this time, or in today's lesson. So then the question becomes, do I shade in those dots or do I leave them open? Well, I don't have the or equal to in my inequality symbol, so I'm just going to leave them open. So X is everything in between these 2 points, or can be. That's my solution set, right? I don't just have one number as an answer when I have an inequality. I have multiple, infinite numbers. So let's move on to the next one. X is greater than or equal to 2 and less than 8. So I have my 2 endpoints here. Oops, that's not what I want to do. I have my 2 endpoints here, 2 and 8. So I'm going to put my dots there, above 2 and above 8. Do I fill in any of these dots? Yes, I have greater than or equal to 2, which means 2 is a part of my solution. It's included in the solution set. So how do I graphically represent that? I shade in that dot. And then X can be anything in between those 2 endpoints. So let's move on to the next set. These are some OR examples. So X is less than or equal to 3, or X is greater than 4. So X is less than or equal to 3. So I'm going to put a dot at 3. And since it's or equal to, I'm going to shade it in. X can be anything less than or equal to 3. So that's how I'd I would graph this on a number line. Or X is greater than 4. So I'm going to put a dot at 4. I'm not going to fill it in because it's just greater than, and I'm going to shade to the right. So let's look at the next one, the last one. X is less than or equal to negative 1. So I'm going to put a closed dot at negative 1, and I'm going to shade to the left. That's less than or equal to. Or X can be any number greater than or equal to 6. Closed dot at 6, and I'm shading to the right. X can be any number over here, including negative 1, or X could also be any number over here, greater than or equal to 6, and it would satisfy the problem that we're looking at. So let's make some observations here. If we're graphing our and inequalities, we have our endpoints. X is everything in between those 2 endpoints. If we're looking at our or inequalities, what do you notice? They go out in either direction, and our endpoints are right there, okay? So that's generally what we're looking at today. And again, I'm not going to graph any kind of special cases or anything today. We're just going to look at ones that model this behavior. So let's look at some examples where we're going to solve compound inequalities with the or in them. Okay, this or that. So the directions say solve each compound inequality, then graph your solution set on the number line provided. So on number 1, if you want, you can draw your line down your inequality, and then I'm going to solve for X. So I'm going to add 5 to both sides. X is greater than or equal to 5. So that's one of my solutions. X is greater than or equal to 5. Or X could also be, so I'm going to draw a line down, and you don't have to. It just helps keep that inequality symbol lined up. Minus 2, and I'm just solving this inequality. It's just a 2-step inequality. Negative 7 minus 2 is negative 9. And then at this point, what do? Divide by 3, and I get X is less than negative 3. So this is one of those or inequalities, so it should typically look like this, right? Go out in either direction. So let's see if it does that. X is greater than or equal to 5. We're going to put a closed dot at 5, and we're going to shade to the right. Or X could also be less than negative 3. So I'm going to put an open dot at negative 3, and I'm going to shade to the left. And so that's what my answer looks like. Let's move on to the next example, number 2. Again, I'm going to draw a line down my inequality symbol, and I'm going to add 4 to both sides. So 6 times X is greater than negative 12. And then again, the goal is to get X all by itself, so what do? Divide by 6, and I get x is greater than -2. Looking at our other one, I'm going to draw a line down my inequality. What do I do first? This is just a two-step inequality. I'm going to add 3 to both sides. -2x is greater than or equal to 16. What do I do now? Divide by -2, and I get x is less than or equal to -8. Why would I get less than or equal to -8? Because I divided by a negative. Okay, so a lot of students go, oh, is it on bottom when it's on bottom? Yes. If I'm dividing by a negative and that negative is on bottom, then I flip my sign. So now let's graph this. X is greater than -2. So I'm going to put an open dot at -2 and I'm going to shade to the right. Or x is less than or equal to -8. Closed dot at -8 and I'm shading to the left. And that's my solution. Let's move on to number 3. So on number 3, I'm going to draw a line down my inequality, and again, you don't have to, but I'm going to subtract 5 from both sides. So I get x is greater than 9. That's one inequality. Or what do I need to do here? I need to distribute this -2 into every term on the inside of the parentheses to get rid of the parentheses. So I'm going to have -2x plus 4 is greater than 10. And now I can just solve my inequality. What do I do first? Subtract 4. -2x is greater than 6. Divide by -2. I'm dividing by a negative. What do I do to my sign? I flip it, or I flip the direction of it, if that helps you understand it better. So instead of pointing to the right, it's going to point to the left. So now let's graph this. X is greater than 9. Open dot at 9, and I'm going to shade to the right. So how do you know which way to shade? I like to say, well, every number to the right of 9 is what is greater than 9. But little trick, if your variable's on the left, which I go over this in my other video, solving multi-step inequalities, I'll put a little card in the upper right corner. If you need help with that, you can click on it. Greater than or equal to, my arrow is pointing to the right, so I shade to the right. All right, let's graph the other one. X is less than -3. So I'm going to put an open dot at -3. That's in between -2 and -4, and I'm going to shade to the left. So let's move on to compound inequalities. What are these going to look like? So these are they're in between two endpoints, if you will. Okay, so I kind of like to draw this as a little reminder that I'm going to have endpoints for these problems when I graph them. So let's look at number 4. I have this problem and I have this problem, and my solution needs to satisfy both of these. I need the solution to this and I need the solution to this. So let's solve. When I'm solving for x, I'm going to add 1 to both sides. 5x is less than 5. And then what do I do now? Divide by 5. X is less than 1. There's one solution. Let's look at the next one. Draw a line down. What do I do first? Subtract 3 from both sides, and I get 4x is greater than or equal to -4. And now what do I do? Divide by 4. Do I flip my sign here? I don't. It does not matter that this is -4 up top up here. That doesn't make you switch your sign. If we were dividing by -4, then we would flip the sign, but we're not. We're just dividing by +4. So the sign stays greater than or equal to, and that's -1. So let's graph this. I need this and this in order to satisfy the solution set. So x can be any number less than 1. That's right there. Open dot, and I would shade to the left. And x can be any number greater than or equal to -1. Well, that's right there. Close dot. So my solution set is in between -1 and 1, and we're including -1 in our solution set. So that's why we shade that in. So that's my answer to number 4. I have those two endpoints. One's at -1, one's at +1. Okay, so you can write this if you want. X, I like to write it like this. My solution set lies between -1 and +1. X is everything in between, which means it's less than 1 and greater than, remember I'm reading from right to left this time, or equal to -1. So this is how you might write your solution set for this one. Let's move on to number 5. So this little bit right here says, sometimes and inequalities are written symbolically in the form A is less than X, which is less than B, and do not require the word and. So I'm going to kind of zoom in here, and I've got this compound inequality written like this. X is in the middle. Your goal is to get X all by itself. So how do I get X all by itself? I'm going to subtract 6 and then divide by 2. But the question is, what do I subtract 6 from and then divide by 2? Well, I have this inequality symbol here and this inequality symbol here. And so what I'm going to do is when I subtract 6, I'm going to subtract 6 from 12 and I'm going to subtract 6 from 8. So I eliminate that 6 from the middle and I'm left with 2x. I've still got my inequality symbol, less than or equal to. 12 minus 6 is 6. Over here, I still have my inequality symbol on this line. 8 minus 6 is 2. So it just looks a little different, but that's how you would solve it like this. Now what do? I'm going to divide by 2. What do I divide by 2? Everything. I'm going to divide 6 by 2, 2 by 2, and I'm left with x in the middle. My inequality symbols have not changed. 6 divided by 2 is 3. 2 divided by 2 is 1. And I love it because it's already written as this compound inequality where x is between, it's less than or equal to 3. So I'm going to put a closed dot at 3. X is everything to the left because it's less than. And x is also anything greater than 1. So my endpoint over here is 1. Open dot, greater than, and it looks like this. What I love when problems or my solution is already written like this, I've got my endpoints, 1 and 3. This lets me know it's going to be a closed dot at 3, that or equal to. There's not one over here with the 1, so it's an open dot, and x can be anything in between. Let's move on to number 6. This is our last one. And again, it's written like this. And so we're going to draw a line down our inequality symbol, and we're going to get x all by itself on the inside of our parentheses. So what do? I'm going to subtract 5, and I subtract 5 from everything over here and over here. So I'm left with negative 2x in the middle, less than or equal to, 9 minus 5 is 4. Negative 3 minus 5 is negative 8. My inequality symbols stay the same. Now what's my next step? I'm going to divide by negative 2, which means I'm going to divide 4 by negative 2 and negative 8 divided by negative 2. Now I've got x all by itself in the middle. So let's get our numbers right first. Let's start over here with negative 8 divided by negative 2. What is that? That's 4. And then 4 divided by negative 2, what is that? That's negative 2. But now, what do I do with my inequality symbols? I divided by a negative. We divided by negative 2. What's the rule when you divide by a negative? What do you do with your signs? You flip them. So let's flip them because that's our rule. So now I've got my compound inequality written like this, but I don't like it written like this where the smaller number is on the right and the larger number is on the left. So you may rewrite this. I'm going to write negative 2 over here, 4 over here, x is everything in between. And when I rewrite it, over here with this negative 2, x is greater than or equal to negative 2. So it's going to look like this, right? So how can you tell that you've rewritten it correctly? Well, we've switched sides, so you got to flip the sign. But this alligator mouth is open to the x, pointing to the -2, it's going to stay open to the x and stay pointing to the -2. So same thing over here. X is less than 4, so it's going to look like that. It's pointing to the x up here. It's going to stay pointing to the x down here whenever I rewrite it. So now when we talk about graphing this, I've got my endpoints of -2 and +4. So there's -2. This or equal to lets me know that I shaded in, and then +4. And x is everything in between because it's less than 4, so to the left, and it's greater than or equal to -2, so to the right. So remember, the solution to and inequalities occurs when the solutions intersect. So the lines on your graph should overlap. So if I were to graph these lines, this one would go all the way this way, and this one would go all the way this way, and this right here, where what we graphed initially, which let me erase what I just drew, that would be where they overlap. If they do not overlap, which we didn't do any examples like this, if they don't overlap, your answer is no solution. But we don't have any special cases today, so you're not going to have any of those. So in summary, compound inequalities are a result of two or more simple inequalities combined by the word or and. So a compound inequality is going to have the word or and in it. Or inequalities only require one solution to satisfy the solution for the compound inequality. This is a union of solutions. And actually on your first page, I gave you the symbol of union, and it looks like a U. It's just fancy schmancy. Fancy schmancy for or. That means or in math. Whereas and inequalities require both solutions to satisfy the solution. So you're going to have an intersection of solutions. So and, if you look at your first page, looks like this. I need this and that. Okay, it's an upside down U. And it's just a fancy schmancy symbol that means and. And that concludes your notes over compound inequalities. I know it was a long set of notes, but I hope you understand them better. So I hope it was helpful.